Alright, so here it wants us to consider point E on the pendulum at the left. It wants to know at point E, is the velocity positive, negative, or zero? Well, right here at point E, the velocity is zero. For a moment, it stops as it changes direction. Okay, so predict if the acceleration at this point, at point E, is positive, negative, or zero. Well, right now we're not sure, so let's take a closer look. To calculate the average acceleration at point E, we need two velocities. Okay, we need the final velocity and the initial velocity. This is going to give us delta V. Okay, it's our change in velocity over time that gives us our acceleration. So let's say that the velocity at point D right here is positive 1 meter per second. So we know that it's moving to the right as it's moving towards point E. And it's negative 1 meter per second after point E. So at point E, after that, it turns around and now it's going to the left, and it's going now negative 1 meter per second. So let's make the time from D back to D 0.5 seconds. So our final velocity is negative 1 meter per second. Our initial was 1, so minus 1, so minus our initial, over a time of 0.5. Negative 1 minus 1 is negative 2. And when we divide that by 0.5, we get an acceleration of negative 4 meters per second squared. So although our velocity was 0, our acceleration was actually negative 4 meters per second squared. So was your prediction correct? Often people think that the acceleration is 0 because the velocity is 0. Remember, a projectile thrown into the air. So take a ball, we throw it into the air. At the very top, right before it starts falling, the velocity is 0 meters per second, but the whole time you always have an acceleration due to gravity of negative 9.8 meters per second squared. So one point cannot define an acceleration. Just because right here the velocity is 0, it still has a very large negative acceleration. Also, if the velocity at D is positive and the velocity at E is 0, then that meant that there was a negative change of velocity and therefore a negative acceleration. Using the same logic, is the acceleration at point A positive, negative, or 0? Well, it went from, at point B, it's probably moving to the left, negative 1 meter per second squared. And then as it approaches A, the velocity equals 0. It's becoming less negative, which would cause a positive acceleration. Or in other words, if it's moving to the left at negative 1 meters per second at B, it's going to be 0 at A, turn around, and be positive 1 meter per second at B. So your final minus initial this time will look like final of 1 minus your initial of negative 1 over 0.5, which is actually 2 over 0.5, or 4 meters per second squared. So again, our velocity might be 0 at either ends, but we have an acceleration. Well, what about at point C, which is here in the center? When the pendulum bob passes the lowest point, is the velocity positive, negative, or 0? Well, right here at A and at E, it has all potential energy. Since it can't go any further down, at point C, all that potential energy is turned into kinetic energy. And kinetic energy is all about velocity. So it has its maximum velocity actually going through point C. So it definitely has a positive velocity. Let's assume that it's moving to the right this time. Predict the acceleration. Okay, we don't know, so we need to find out. Notice that at point B, it's the same height as at point D. So if you're taking one full swing to the right, it's going to be going to the right, so the velocity at B is going to be equal to the velocity at D since they have the same height. Now let's again use positive 1 meter per second at velocity at point D, therefore we must have positive 1 meter per second at point B. Okay, remember, we're going basically from A to E to the right, so going through B and D, we're moving to the right. Both times we have a velocity of 1 meter per second. If the time from B to D is, it should say, 0.75 seconds, calculate the average acceleration. Okay, so our final velocity is 1, minus our initial velocity of 1 over 0.75. Well, 1 minus 1 is 0. It doesn't really matter what you're dividing it by. Your acceleration is 0 meters per second squared. So is your prediction correct? Notice that in this case the acceleration is at a minimum, 0, but the velocity is at a maximum. Okay? Kind of counterintuitive, but if you think about it this way, so let's recap part 1. At either end, at the extreme, so let's say at point E, if you were to pull a pendulum back and let it go, it's going to start swinging. Okay? The fact that you could move it to the side and let it go and it will start moving, there must be some force, some component of the force of weight that's acting on it. If there's a force present at this point, there's going to be an acceleration present at this point, because force equals mass times acceleration. If you were to place a pendulum at this point and let it go, it's going to stay right here. So at this point, there's actually no force that's being able to cause it to move at this point, therefore no acceleration. So, at the extremes, in other words, points A and E, our acceleration is at a maximum, while our velocity is at a minimum, 0. At the center, we have the opposite. Our velocity is at a maximum, but our acceleration is at a minimum.